Hello everyone, welcome to this video. Today I want us to do something very special, something you don't want to do in production. So think about this. Imagine you are in a dream, we all love to dream, right? I don't know if you have seen the movie Inception, but I have seen it. I think it's one of the best movies of all time. Now, pointers in any programming language like C, Go, anywhere, pointers are the same. They point to an address in memory. So, but what can point to a pointer? What if you want to, for example, you have a pointer that points to another pointer, 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 that can, then it continues like this forever. What do you think would happen? This is what I think in my head is like you are in a dream, then you go into a different dream, another dream, another dream, another dream. Maybe at this fourth level, you're having a nightmare, you want to get out. But then in another dream, you wake up, so you're like, oh my goodness. So today I want to show you some sort of crazy pointer referencing that I don't think you want to do in production. You definitely don't want to do it in production. Well, let's go very simple, very simple. Now, the takeaway from this video is no matter the depth, no matter how deep you go into the pointer, it points to the same data. Even though the different variables would point to an address, when you resolve that address, you are going to be pointing back to the data. So let's start with something basic. Let's start with something that we can all relate with. Let's say a life decision pointer, right? Something simple. And then, by the way, if you've not subscribed to my channel, don't forget to subscribe. And remember, please, you can like the video, you can share it. If you don't like it, you can dislike it, but leave me a comment, give me some feedback. So anyhow, let's do it. Bad decision. Something I'm going to write that probably is going to annoy some people. So let's say life decision. I put decision here. What could be a bad decision in life? Let's say you skipped your you keep studying. You skipped studying to watch the latest Game of Thrones. Right. This for me, I think this is a bad life decision. Don't want to do this. Right. Let's make a second bad decision. This one is going to make you laugh, probably. Decision. What? Order a pizza at 2 a.m. Come on, people, don't do that. And then let's print it to the screen. This is no pointer yet. We haven't done any pointer thing yet, so just enjoy my typing and the explanation for now. After, we're going to see, so bad decision. Before I print this, okay, let me come here and do something. Let's say var first step, right? The first step of our life, we are going to say it's a pointer. Let me comment this out. We'll come back here because this is what I want to print. Let's make this a pointer. This is a pointer type now. This is important. It points to the first bad decision we made. Then var, the second step we took, was another bad decision that points to second bad decision. All right, so here I'm going to print the first one and the second one. First bad decision would be first step dot decision. One good thing in Go is you don't need to dereference when the pointer is just one like this. Go does the dereferencing for you. It's magic. Don't tell anyone. All right. Then this next step in our bad decision, making is going to be second step. Okay, so we have the two. This, no surprises so far. I can go ahead and run it. If you want, you can run from the command line. So we have what we asked for. There's nothing special here. Maybe I should run from the command line just for the sake of those who doesn't use IntelliJ. I'm going to switch to Bash. I'm switching to Bash because I have autocomplete in the second terminal and I don't want it to be displaying what I have typed previously in my own personal project. So I run the 001 and you see, okay. Now, where is the fun part? The fun part is so we can say var next step. This next step, remember next step is currently pointing to one pointer, okay? And then we can say next step, sorry, this is first step. So I want to do next step. First step is pointing to a pointer. So we're going to do next step, 2 pointers now, this time around. And then we point it to the first step. And with that, we can come here and print something like this. And we are back to, let's say back to next step. This is decision. Here we need to dereference it ourselves. And read like this. So one interesting thing here is the fact that we are back to where we started. Because if you think about it, we have 2 levels. So the first level was here, second level went here, and then we went back. Now, I rarely see anyone interacting with pointers like this, like 2 pointers. People don't do it. I don't think anyone is going to write code like this in production, honestly. If you have seen before, please let me know. But I don't think anyone writes code like this in production. So this is one. The most exciting one is the second one I want to talk about now. So if you have any comment, please leave it. Put it in the comment section. Let's do the second one. 002. All right. This is the really, really cool one. Okay, let's start with rabbit hole. Type rabbit hole. I think we can do it like this. And level would be a string. And make the level integer, but I'm going to keep it a string because I'm going to have just one level. So the first thing I want to do, let me close this one off. Maybe I can expand it a little bit. Let's say base. This is the beginning of our dream. Oh, rabbit hole. And then level. We are the base level. Right? Now let's work on all the levels. So I'm going to say var p1 pointer rabbit hole. This is the first pointer. It's going to point to the base. So this is our first pointer. And it gets more interesting. I'm going to duplicate it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to start. This is 1, 2, 3, 2, 3, 4 now. So let's keep adding the number. So this is going to be number 2, number 3, number 4. You see how I don't want to use the word that came to my mind, but you see how it looks tricky and error prone. So this is why you don't want to do this in production, right? And this is 4, 5, 6. So we are the 6th level. You can actually do any level you want. 6, 7. In order for us to track the error, let's keep doing it. So this one is pointing to P1. This is going to point to P2. This is going to point to P3. This is going to point to P4. This is going to point to P5. This is going to point to P6. Okay. Then we have 6, 7 there, 8, 9, and 10. If you count here, we have 3 and 4. So 1, 2, 3, 4, 5, 6, 7, 8. So we should be pointing to P7. All right. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we should be pointing to P8. The last one, I think we can copy this one over here and point to P9. Do you see the depth of our pointer? This is valid Go code, and you can come here and let's print something out. Data at level 10 is, you want to dereference it completely like it is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you can put level. And this is it. You are able to print. We can go ahead now, print, go, run 002. And you have it. You see, this is the data at level 10 and this base. So when we dereference the pointer, even at this depth, we are still pointing to the base. We are still pointing to the real data. This is the data that we have. Every other thing is basically like passing a torch, just creating a chain. And another way to think about pointers like this is a linked list that is in one direction. But there is something more interesting. What if instead of doing this, is there a way we can think about this? Because this is like a linked list, right? That means if we pass, let's say we pass P1, can we use the information from P1 to get to the highest level? Or sorry, when we pass P10, can we go back until we go to base? Basically going through the pointers. Let's give it a shot. Maybe we have a function called print level, something like this, and pass it P10. This is going to be a little tricky, but let's think about it. I can say func, I mean it's a pointer that I'm going to name it. It can be interface here, okay? Interface, you can also use any, it's an alias of interface. All right, this is going to be our depth. Let's start at 0, and the current value would be, I'm going to use reflection here. If you think there is a better way to do it, reflect dot value of reflect REFL reflect. So I'm just going to use value of, okay, value of pointer. Now this is the interesting part, because here if you give it a non-pointer value, we don't really want to do anything, but we want to make sure that it's a pointer. That's why I'm using reflection. So I'm going to say for current, this is how you work with linked list. If the kind is reflect this pointer, that means this loop can continue when, as long as it's a pointer, it continues. This is exactly how we work with linked list. So we need to set this current here to current dot element. This is what is going to cause the loop to exit as soon as we hit the struct itself, which is no longer a pointer. We exit the loop. So this is good. Next, we can increment the depth. And I'm just going to print some information out here, nothing special, just for you to see what we are doing. Level, and maybe we can use the V like this, and I can pass it new line. We can pass it current dot interface or something. Yeah, interface. Right, what else? Say no argument. I'm using, where am I making mistake? Oh, I forgot to put depth here. Okay, thank you, ID. So this is everything. Then lastly, we need to come here and do another printf. and I can say reached the final level. This is the final level with value. The value is still wrapped, so if you want, you can unwrap it, but I'm going to use the same interface. And this is it. What else? What is it saying? No argument. Same thing, same mistake I made there. I didn't pass the depth. So this is what we have, and it's time to run it. Fingers crossed. I think we should comment out this one. Okay, it worked. So basically, we started from that first level until we hit the 10th level, and then as soon as we hit the struct, we printed it out. What if we change it to, we give it, let's say, P4. We start from P4 instead, and we run it again. The rest, okay, Go won't want this to happen. Just, then maybe if we're going to give it, let's say P4, we can comment out everything here and run it. And then it worked, the same thing. So very powerful concept, but for sure, this is not a code you want to use in production. But the takeaway is this: there are many interesting things you can do with pointers, really cool stuff. You can do like a loop, so a pointer to a pointer, then in turn point to that pointer, basically like a loop. And I think that's how loops are done in assembly, when you don't have like for and for each statement. So yeah, great video. If you enjoyed the video, the little concept, please don't forget to subscribe, like, share, and thank you for watching. Bye for now.